Welcome to this explainer on Tommy from FreeCodeCamp's masterclass on JavaScript testing with Jest. Look, if you've ever felt the absolute agony of a bug in production that you literally swore worked perfectly on your local machine, well, this is for you. We're going to take Jest and completely transform it from this tedious chore you have to do into your absolute most powerful tool. It's going to become the ultimate safety net for your code. So here's our agenda. We're hitting 5 key areas today. First, the testing playground. Second, your first unit test. Third, mastering Jest matchers. Fourth, taming asynchronous code. And finally, number 5, mock functions and spies. We've got a lot of ground to cover to get you writing that bulletproof code, so let's just dive right in. Section 1, the testing playground, setting up your Jest environment. We're going to start things off by building a low-stakes environment where you can safely mess around and experiment without, breaking your actual applications. Getting a project initialized is super quick. You just create a directory from your command line using mkdir, then run npm init-y to entirely bypass all those tedious default prompts, and finally install Jest locally. Now, expanding on that last step for a second, that --save dev flag, that is absolutely crucial. It tells your project that Jest is essential for building and testing, but it ensures it won't bloat your final deployed application. It stays strictly fenced inside your development environment. Next, to make our lives infinitely easier, we're going to tweak the package.json manifest. By changing the default test script value from its standard clunky error message to simply the word Jest, you ensure that typing npm test in your terminal kicks off your entire testing suite automatically. And just like that, with one tiny tweak, your playground is officially open for business. Moving right along to Section 2, your first unit test, building a solid foundation. With our playground all set up and ready to go, let's grab our first actual tool out of the belt. You really need to think of unit testing as your absolute first line of defense. Because instead of testing the entire massive application at the very end, where finding a bug is quite literally like finding a needle in a haystack, we isolate these small logic blocks. The goal here is to deliver information early and often. Trust me, it saves you hours of debugging spaghetti code later down the line because you know exactly what failed and exactly why it failed. Here's how it flows. You export your logic, let's say it's just a simple addition function, and you require it in a dedicated file named sum.test.js. Jest is actually super smart. It automatically hunts down any files with .test in the name. Then you write a quick description of what should happen, and honestly, just look at that syntax. It reads almost perfectly like plain English. You expect the sum of 1 and 2 to be 3. Running npm test and seeing that first bright green passed message pop up, so incredibly satisfying. All right, Section 3, mastering Jest matchers, the right tool for the right job. We know how to test basic numbers now, but how on earth do we test more complex data structures? So JavaScript has this quirk where two identical objects aren't necessarily the same thing in memory. If you try to use to to compare two identical objects, Jest is actually going to fail your test. Why? Because it's looking at the raw memory address, not the actual contents. That is exactly why we reach for to instead. It recursively and smartly checks every single property inside complex values, like dictionaries or arrays, to make sure they map perfectly to one another. Now, JavaScript also has a notoriously quirky relationship with what it considers empty. A zero, a null, a false, or an undefined, those are all treated as falsy. If you need a test that simply ensures a variable is empty, .toBeFalsy is your go-to move. Conversely, if you want to make absolutely sure an API returned any valid data at all, you test that it is .toBeTruthy. But, great developers don't just test the happy path. They test for total disasters. If your function requires a number, but some user passes in a text string, your code should throw an error. The .toThrow matcher allows you to actually test that your application successfully catches and handles that exact mistake under specific invalid conditions, rather than just silently crashing in the background. Okay, let's step it up. Section 4, taming asynchronous code, handling operations in the background. We need to break out the power tools here, because modern JavaScript constantly relies on background operations that absolutely should not block the main thread. Luckily, Jest gives us 3 totally distinct methods to gracefully test these background operations: callbacks, promises, and async await. The key here is that we have to literally teach Jest how to wait. Otherwise, our tests might fail prematurely while the background task is still out there running. Think about it like this. What if our code has a delayed API call returning the string peanut butter? If a test finishes executing before that delayed data actually arrives over the network, Jest just passes the test by default. That's a false positive. And honestly, it's incredibly dangerous. We have to figure out a way to pause our execution while we're waiting for this delicious, delayed callback to arrive. Our first solution for this is the done callback parameter. It acts kind of like a manual override switch. You literally pass the word done into your test function, write your logic to test for the peanut butter, and then call done as a function at the very end to signal completion. It basically tells Just, okay, hey, the background work is totally finished. Now you can go ahead and grade the test. But when we're testing promises, it gets even better. Jest gives us these incredibly readable .resolves and .rejects matchers that handle success or failure directly right there in the expectation chain. Instead of dealing with messy callback functions, you literally just say, I expect this promise to resolve, and when it does, it should be peanut butter. It reads exactly like plain English, making network request testing an absolute breeze. And to avoid messy nested chains or, callback hell entirely, modern JavaScript heavily favors async and await. Pausing the test with await before making your assertions gives us a dramatically cleaner, much more readable syntax. Jest will literally freeze on that specific line of code, wait patiently for the promise to settle and the peanut butter to arrive, and only then will it move on to verify the matcher. We've made it to the last section, Section 5, Mock Functions and Spies, Advanced Code Isolation. For our final set of tools, we really need to talk about isolating your code from highly unpredictable external factors. So ask yourself, how do you test a database call without touching the actual database? If you're relying on a live production database, your test could fail just because the office Wi-Fi dropped. Or worse yet, actually touching a real database during an automated test could accidentally delete real user data. That is a massive risk. True unit testing means testing your logic, not testing if your cloud provider is currently online. To solve this massive headache, we use two entirely different diagnostic tools, mocks and spies. Think of mocks as Hollywood stunt doubles. They provide completely fake implementations, totally replacing your slow or dangerous real functions. So if you have a function that charges a credit card, you obviously use a mock to fake the success. But if you just want to track behavior without replacing the actual logic, like knowing if a video's play button was triggered, you'd use a spy. Using jest.fn, we can create a completely fake function right on the spot, say, one that just adds 42 to a variable. It entirely isolates the logic, acting like this little black box that just records exactly how your code interacted with it. Then, you use a super handy matcher like .tall times held with to ensure that fake function received the exact correct metadata and inputs. Conversely, if we want the actual video to play, but we just want to quietly track it happening, we attach just.spyOn to the object method. It sits stealthily in the background, letting the real code execute without altering its actual logic one bit. But it keeps a highly detailed ledger of every single interaction. Then you can write an expectation verifying that your internal methods are triggering at the exact right time. Now, once our spying is all done, we have to clean up. We use mock restore, which is a method used on a spy, to revert the spied function entirely back to its original implementation. We do this to prevent what's called test pollution. Basically, ensuring a spy left active in one test doesn't secretly ruin the results of the next test down the line. It guarantees every single unit test remains perfectly isolated. At the end of the day, testing absolutely doesn't have to be a chore. It really is your ultimate safety net. So I want you to look at your own codebase today. Ask yourself, are you catching bugs in your local testing playground, or are you letting your users find them for you out in production? Stop waiting for production to find your bugs. Start testing early and often. So what piece of your code are you going to test first? Until next time, keep exploring and keep building.